The Boeing E-3 Sentry, commonly known as AWACS, is an airborne early warning and control aircraft developed by Boeing as the prime contractor. Derived from the Boeing 707, it provides all-weather surveillance, command, control, and communications, and is used by the United States Air Force, NATO, Royal Air Force, French Air Force, and Royal Saudi Air Force. The E-3 is distinguished by the distinctive rotating radar dome above the fuselage. Production ended in 1992 after 68 aircraft had been built. In the mid-1960s, the U.S. Air Force was seeking an aircraft to replace its piston-engined Lockheed DC-121 Warning Star, which had seen service for over a decade. After issuing preliminary development contracts to 3 companies, the USAF picked Boeing to construct 2 airframes to test Westinghouse Electric and Hughes's competing radars. Both radars used pulse Doppler technology, with Westinghouse's design emerging as the contract winner. Testing on the first production E-3 began in October 1975. The first USAF E-3 was delivered in March 1977, and during the next 7 years, a total of 34 aircraft were manufactured. NATO, as a single identity, also had 18 aircraft manufactured, basing them in Germany. The E-3 was also sold to the United Kingdom and France and Saudi Arabia. In 1991, when the last aircraft had been delivered, E-3s participated in Operation Desert Storm, playing a crucial role of directing coalition aircraft against the enemy. Throughout the aircraft's service life, numerous upgrades were performed to enhance its capabilities. In 1996, Westinghouse Electric was acquired by Northrop before being renamed Northrop Grumman Electronic Systems, which currently supports the E-3's radar development. Background: in 1963, the USAF asked for proposals for an airborne warning and control system to replace its CC-121 Warning Stars, which had served in the airborne early warning role for over a decade. The new aircraft would take advantage of improvements in radar technology which allowed airborne radars to look down and detect low-flying aircraft, even over land, which was previously impractical due to ground cluster. Contracts were issued to Boeing, Douglas, and Lockheed, the latter being eliminated in July 1966. In 1967, a parallel program was put into place to develop the radar, with Westinghouse Electric and the Hughes aircraft being asked to compete in producing the radar system. In 1968, it was referred to as overland radar technology during development tests on the modified EC-121Q. The Westinghouse radar antenna was going to be used by whichever company won the radar competition. Since Westinghouse had pioneered in the design of high-power RF phase shifters, Boeing initially proposed a purpose-built aircraft, but tests indicated it would not outperform the already operational 707, so the latter was chosen. Instead, to increase endurance, this design was to be powered by 8 General Electric TF-34s, or carrying its radar in a rotating dome mounted at the top of a forward-swept tail, above the fuselage. Boeing was selected ahead of McDonnell Douglas's DC-8-based proposal in July 1970. Initial orders were placed for 2 aircraft designated EC-137D as testbeds to evaluate the 2 competing radars. As the testbeds did not need the same 14-hour endurance demanded of the production aircraft, the EC-137s retained the Pratt & Whitney JT3D commercial engines, and a later reduction in endurance requirement led to retaining the normal engines in production. The first EC-137 made its maiden flight on 9 February 1972, with the fly-off between the 2 radars taking place during March-July that year. Favorable test results led to the selection of Westinghouse's radar for the production aircraft. Hughes's radar was initially thought to be a certain winner, simply because much of its design was also going into the new F-15 Eagles radar program. The Westinghouse radar used a pipelined fast Fourier transform to digitally resolve 128 Doppler frequencies, while Hughes's radars used analog filters based on the design for the F-15 fighter. Westinghouse's engineering team won this competition by using a programmable 18-bit computer whose software could be modified before each mission. This computer was the AN AYK-8 design from the B-57G program, and designated AYK-ATP-1 for its much expanded memory. This radar also multiplexed a beyond-the-horizon pulse mode that could complement the pulse Doppler radar mode. This proved to be beneficial, especially when the BTH mode is used to detect ships at sea when the radar beam is directed below the horizon. Full-scale development approval was given on 26 January 1973 for full-scale development of the AWACS system. To allow further development of the aircraft's systems, orders were placed for 3 pre-production aircraft, the first of which performed its maiden flight in February 1975. To save costs, the endurance requirements were relaxed, allowing the new aircraft to retain the 4JT3D engines. IBM and Hazeltine were selected to develop the mission computer and display system. The IBM computer receiving the designation 4PI, and the software is written in Jovial, a semi-automatic ground environment or backup interceptor control operator would immediately be at home with the track displays and tabular displays. But differences in symbology would create compatibility problems in tactical ground radar systems in Iceland, Europe, and Korea over Link 11. Modifications to the Boeing 707 for the E-3 Sentry included a rotating radar dome, single-point ground refueling, air refueling, and a bailout parachute. The original design called for 2 bailout parachutes, but the aft bailout parachute was deleted as a way to cut mounting costs. Engineering, test and evaluation began on the first E-3 Sentry in October 1975. Between 1977 and 1992, a total of 68 E-3s were built. Future status: because the Boeing 707 is no longer in production, the E-3 mission package has been fitted into the Boeing E-767 for the Japan Air Self-Defense Forces. The E-10 MC-2A was intended to replace USAF E-3s, along with the RC-135 and the E-8, but the E-10 program was cancelled by the Department of Defense. The USAF is now performing a series of incremental improvements, mainly to avionics, to bring the E-3 up to current standards of performance. Boeing is flight testing its Block 4045 E-3s. This modified E-3 contains upgrades of the mission crew and air battle management sections, as well as significantly upgraded electronic equipment. Another program that the Air Force is considering is the Avionics Modernization Program. AMP would equip the E-3s with glass cockpits. The Air Force also wants modified E-3s with jet engines that are more reliable than the original ones, and also with at least 19% higher fuel efficiencies. New turbofan engines would give these E-3s longer ranges, longer time on station, and a shorter critical runway length. If the modification is carried out, the E-3s could take off with full fuel loads using runways only 10,000 feet long, and also at higher ambient temperatures and lower barometric pressures, such as from bases in mountainous areas. Now that the E-8 joint stars are being fitted with the new Pratt & Whitney JT8D219 turbofans, which are stated as having one-half the cost of the competing engine, the CFM56. The Air Force is again studying the possibility of replacing the E-3's original turbofan engines with more efficient ones. Upgrading NATO's E-3 fleet is complicated by the heterogeneity of the fleet's equipment. Each NATO member's E-3 aircraft are configured differently, and NATO has not finalized upgrade or replacement plans. The airplanes themselves can be flown to 2050 with appropriate maintenance, but as the worldwide fleet of 707 aircraft dwindles, supporting the E-3 becomes more difficult. Design overview: The E-3 Sentry's airframe is a modified Boeing 707-320B advanced model. USAF and NATO E-3s have an unrefueled range of some 4,000 miles or 8 hours of flying. The newer E-3 versions bought by France, Saudi Arabia, and the UK are equipped with newer CFM56-2 turbofan engines, and these can fly for about 11 hours or about 5,000 miles. The Sentry's range and on-station time can be increased through air-to-air refueling, and the crews can work in shifts by the use of an onboard crew rest and meals area. When deployed, the E-3 monitors an assigned area of the battlefield and provides information for commanders of air operations to gain and maintain control of the battle, while as an air defense asset. E-3s can detect, identify, and track airborne enemy forces far from the boundaries of the US or NATO countries and can direct fighter-interceptor aircraft to these targets. In support of air-to-ground operations, the E-3 can provide direct information needed for interdiction, reconnaissance, airlift, and close air support for friendly ground forces. Avionics: The unpressurized rotordome is 30 feet in diameter, 6 feet thick at the center, and is held 11 feet above the fuselage by two struts. It is tilted down at the front to reduce its aerodynamic drag, which lessens its detrimental effect on takeoffs and endurance. The dome uses both bleed air and cooling doors to remove the heat generated by electronic and mechanical equipment. The hydraulically rotated antenna system permits the Westinghouse Corporation's APY-1 and APY-2 passive electronically scanned array radar system to provide surveillance from the Earth's surface up into the stratosphere, over land or water. Other major subsystems in the E-3 Sentry are navigation, communications, and computers. Consoles display computer-processed data in graphic and tabular format on video screens. Console operators perform surveillance, identification, weapons control, battle management and communications functions. The radar and computer subsystems on the E-3 can gather and present broad and detailed battlefield information. This includes position and tracking information on enemy aircraft and ships, and location and status of friendly aircraft and naval vessels. The information can be sent to major command and control centers in rear areas or aboard ships. In times of crisis, data can be forwarded to the National Command Authority in the U.S. via RC-135 or Naval Aircraft Carrier Task Forces. Electrical generators mounted on each of the E-3's 4 engines provide the 1 megawatt of electrical power that is required by the E-3's radars and other electronics. Its pulse Doppler radar has a range of more than 250 miles for low-flying targets at its operating altitude, and the pulse radar has a range of approximately 400 miles for aircraft flying at medium to high altitudes. The radar, combined with an SSR, provides a look-down capability to detect, identify, and track low-flying aircraft, while eliminating ground clutter returns. Upgrades starting in 1987, USAF E-3s were upgraded under the Block 3035's modification program to enhance the E-3's capabilities. On 30 October 2001, final airframe to be upgraded under this program was rolled out. Several major enhancements were made. Firstly, the installation of electronic support measures and an electronic surveillance capability for both active and passive means of detection. The Joint Tactical Information Distribution System provides rapid and secure communication for transmitting information, including target positions and identification data, to other friendly platforms. Global positioning system capability was also added. Onboard computers were also overhauled to accommodate JTIDS, Link 16, the new ESM systems, and to provide for future enhancements. The Radar System Improvement Program was a joint U.S.-NATO development program. RSIP enhances the operational capability of the E-3 radar's electronic countermeasures, and dramatically improve the system's reliability, maintainability, and availability. Essentially, this program replaced the older transistor logic and emitter-coupled logic electronic components, long since out of production, with off-the-shelf digital computers that utilized a high-level programming language instead of assembly language. Significant improvement came from replacing the old 8-bit in FFT with 24-bit FFDs, and the 12-bit AD with a 15-bit AD. These hardware and software modifications improved the E3 radar's performance, providing enhanced detection with an emphasis towards low radar cross-section targets. The RAF had also joined the USAF in adding RSIP to upgrade the E-3's radars. The retrofitting of the E-3 squadrons were completed in December 2000. Along with the RSIP upgrade was installation of the Global Positioning System, inertial navigation systems which dramatically improve positioning accuracy. In 2002, Boeing was awarded a contract to add RSIP to the small French AWACS squadron. Installation was completed in 2006. Operational history. In March 1977, the 552nd Airborne Warning and Control Wing at Tinker AFB, Oklahoma received the first E-3 aircraft. The 34th and last USAF Sentry was delivered in June 1984. In March 1996, the USAF activated the 513th Air Control Group, an ACC-gained Air Force Reserve Command AWACS unit under the Reserve Associate Program, collocated with the 552 ACW at Tinker AFB, the 513 ACG, which performs similar duties on active-duty E-3 aircraft shared with the 552 ACW. The USAF have a total of 31 E-3s in active service. 27 are stationed at Tinker AFB and belong to the Air Combat Command. 4 are assigned to the Pacific Air Forces and stationed at Kadena Ave, Okinawa, and Elmendorf AFB, Alaska. 1 aircraft was assigned to Boeing for testing and development. In 1977, Iran placed an order for 10 E-3s. However, this order was cancelled following the 1979 revolution. NATO acquired 18 E-3s and support equipment for a NATO air defense force. Since all aircraft must be registered with a certain country, the decision was made to register the 18 NATO Sentries with Luxembourg, a NATO member that previously did not have any air force. The first NATO E-3 was delivered in January 1982. The 18 E-3s were operated by No. 1, 2 and 3 squadrons of NATO's E-3 component, based at NATO Air Base Guilenka-Chen. Presently 17 NATO E-3s are in the inventory, since 1 E-3 was lost in a crash. The United Kingdom and France are not part of the NATO E-3A component, instead procuring E-3 aircraft through a joint project. The UK and France operate their E-3 aircraft independently of each other and of NATO. The UK operates 6 aircraft and France operates 4 aircraft, all fitted with the newer CFM56-2 engines. The British requirement came about following the cancellation of the British Aerospace Nimrod AEW-3 project to replace the Avro Shackleton AEW-2 during the 1980s. The UK E-3 order was placed in February 1987, with deliveries starting in 1990. The other operator of the type, delivered between June 1986 and September 1987, is Saudi Arabia, which operates 5 aircraft, all fitted with CFM56-2 engines. This particular sale was hotly contested between the Reagan administration and opponents of the sale. E-3 Sentry aircraft were among the first to deploy during Operation Desert Shield, where they immediately established as an around-the-clock radar screen to defend against Iraqi forces. During Operation Desert Storm, E-3s flew 379 missions and logged 5,052 hours of on-station time. The data collection capability of the E-3 radar and computer subsystems allowed an entire air war to be recorded for the first time in history. In addition to providing senior leadership with time-critical information on the actions of enemy forces, E-3 controllers assisted in 38 of the 41 air-to-air kills recorded during the conflict. NATO and RAF E-3s participated in the international military operation in Libya. On 27 January 2015, the RAF deployed an E-3 Sentry to Cyprus in support of US-led coalition airstrikes against Islamic State militants in Iraq and Syria. The Sentry joins RAF Panavia Tornado, MQ-9 Reaper, and air tanker Voyager aircraft performing or supporting almost daily strikes against militants. On 23 June 2015, the first of the original 18 NATO E-3A AWACS aircraft to retire arrived at Davis Monthan AFB near Tucson, AZ. The aircraft Luxen 90449 will be placed in parts reclamation storage where critical parts will be removed by NATO technicians to support their remaining fleet of 16 Boeing E-3A aircraft. It had accumulated 22,206 flight hours between the 19th of August 1983 and the 13th of May 2015 and operated out of 21 different countries in support of NATO operational activities. The aircraft was due in mid-July 2015 for a 6-year cycle depot-level maintenance inspection which would have been very costly. Without the inspection, the aircraft would no longer be allowed to fly. The so-called 449 retirement project will result in reclamation of critical parts with a value of upwards of $40 million. Some of the parts to be removed are no longer on the market or have become very expensive. On 18 November 2015, an E-3G was deployed to the Middle East to begin, immediately, flying combat missions in support of Operation Inherent Resolve against ISIL, marking the first combat deployment of the upgraded AWAC Block 40/45. The $2.7 billion development effort started in 2003, with the first 5 aircraft achieving initial operational capability in July 2015. The Block 40/45 upgrade is the most extensive the E-3 has undergone, replacing its 1970s computer technology with an early 2000s standard and including a deployable ground system that receives, processes, and disseminates data. The Air Force plans to convert 24 AWACS to E-3G standard, while retiring 7 from the fleet to avoid upgrade costs and harvest out of production components. Variants: EC-137D2 prototype AWACS aircraft with JT-3D engines, one fitted with a Westinghouse Electric radar and the other with a Hughes Aircraft Company radar, both converted to E-3A standard with TF-33 engines. E-3A production aircraft with TF-33 engines and an APY-1 radar, 24 built for USAF, later converted to E-3B standard. Total of 34 ordered, but the last 9 completed as E-3C. 1 additional aircraft retained by Boeing for testing, 18 built for NATO with TF-33 engines and 5 for Saudi Arabia with CFM56 engines. KE-3A. These are not AWACS aircraft but CFM56 powered tankers based on the E-3 design. 8 were sold to Saudi Arabia. E-3B. E-3 is with improvements, 24 conversions. E-3C production aircraft with an APY-2 radar, additional electronic consoles and system improvements, 10 built. JE-3C-1 E-3A aircraft used by Boeing for trials, later redesignated E-3C. E-3D production aircraft for the Royal Air Force to E-3C standard with CFM56 engines and British modifications designated Sentry AEW-1, 7 built. E-3F production aircraft for the French Air Force to E-3C standard with CFM56 engines and French modifications, 4 built. E-3G USAF Block 40 45th modification includes hardware and software upgrades to improve communications, computer processing power, threat tracking, and others, and automates some previously manual functions. IOC reached in July 2015.